All right, guys, we're going to start chapter 3. We're going to get into systems of equations. We're going to focus on tables and graphs because you should be familiar with most of this from Algebra 1. Somewhere in December or January last year, you were working on these. Function notation, normally with the warm-ups, I don't do much with these, but for the second one, I want to make sure I show you that because that's an SAT style question because we think we know, but sometimes we get confused. So let's take care of the first one first. F of 3, so it's 3 times 3 squared plus 5 times 3 minus 12. So 3 squared is 9 times 3 is 27 plus we got 15 here minus 12. All right, so we're at 42 minus 12. So we got 30 as our final answer. And then I don't want to forget, I got to multiply that by 3. Yeah, I'll be honest. I almost forgot, right? But I knew there was something extra with this one. So we're going to multiply by 3. The reason I want to point this one out is the second equation. Typically, you notice how this said f of 3, so that means take that 3 and put it into the equation where the x was. Notice we don't have that this time. So this is 7x plus 12 is supposed to be equal to negative 8. So it's a lot like using substitution that we're going to use in this section or in this chapter. So I might subtract 12, so 7x equals negative 20, and then just divide it by 7, and that becomes our final answer. So keep in mind, if it doesn't tell me to replace the variable itself with a number, if it just says set it equal to, then we're going to treat it differently because it is written differently with that notation. All right, so hopefully that makes some sense to you. All right, 3 things can happen. We're going to graph 2 lines. Thing number 1 that can happen is they cross over at one place. So I got one solution. And it's going to be whatever that ordered pair is, right? We have x, y. So let's call this line 1, this line 2. So what do we know? We know the slope of line 1 is not equal to the slope of line 2. And if that happens, we're going to get one solution all the time if the slopes are different. So our situation 2 and 3, we can tell that the slopes are the same. 3 looks a little bit tricky. I'll talk about that in a second. So this is line 1, this is line 2. So my slope of line 1 is equal to the slope of line 2. But notice I have different y-intercepts. Okay, so we know that these are parallel lines. So B1 is not equal to B2. But if they never cross, will they ever get that solution where they cross? No. So there's no solution here. No solution. And then the last one, this one looks a little bit tricky. So let me show you the other line. Here's the other line. Okay. So what happens now is this is line 1 and line 2. So the slopes are the same and the y-intercepts are the same. And we're looking for the point that they share. And it just so happens that they share all of them. So we do better than one solution. We go with all real numbers. So we have infinitely many solutions. So this is what's happening here. These are the 3 things that can happen. Now we have a little bit of vocab that we talked about. So names for the 3 solutions we can get. So we had one solution. If I get a solution, it's called consistent. So that means I had one solution consistent, all real numbers, that is a solution, so it's consistent. Right? If I don't get a solution, it's called inconsistent. Inconsistent. Now, if I can get a solution, I need a vocab term that helps delineate between one versus the other. So here's what happens. If you are one person and you can take care of yourself, you are independent. So that means you are consistent, independent if we get one solution, which happens, honestly, the majority of the practice that we do. Now, I'm going to make sure that the other things happen, but with most lines, most systems we're going to work with in Algebra 2, we'll have different slopes. Okay, inconsistent, we don't need a second qualifier on it. That means parallel lines. That means there's no solution. Okay, so this is all vocab. So if you need to, you're going to make some vocab cards out of this. The next one that we have is we have the one line, right? We have a line and we have the other one that's right on top of it, right? You can see that, the yellow highlighter and the other one on my pens here in the little picture. This is much like most kids your age. You are dependent, right? Because you live at your parents' house or grandma's, your aunt, uncle, whatever it is, you are dependent. And that's to be expected because you're at school full time. So it's hard to have enough money to have your own house and your own car and all those things. Okay. So just trying to tie in that vocabulary. So independent means one that can take care of themselves. So that's one solution. Dependent means you still, you depend on other people. Well, this yellow line is laying right on top of that maroonish line. Okay, so they're dependent upon each other. They share all the points, what makes it all real numbers. Okay, so that's the vocab. And those are the three things we can get. So the one thing we had to do in this section was to graph the lines. These are both in slope-intercept form, so it's kind of the easiest review we can do. So here's my first point. Okay, I used my y-intercept to -2. My slope is 3 over 1, 1, 2, 3, up 1, up 3 over 1. All right, then I'm going to connect these two. 1, 2, 3. Now, because I'm trying to find a nice ordered pair that they cross, I would just extend by counting some more, right? 1, 2, 3 over 1, 1, 2, 3 over 1. And now I can make a pretty nice line out of the whole thing. Because one thing I noticed right away is this has a slope of 3. That's a terrible color. Okay, so this one has a slope of 3 and this one has a slope of -1. So they're going to cross somewhere. That's a given. Okay, next one we're going to start at -6. And then we're going to use -1 as the slope. So I'm going to go down 1 and over 1. And I want this to happen in the other direction. So I'm going to circle that because that's my answer already. But I do want to finish drawing my graph so I know what it is. All right, so here's like the $20,000 question. What's that ordered pair? Okay, make sure we are tracing the x value first. So -1, and it's down at -5. How do I know? I can plug these in for x and get the y value. Right? And it has to work for both of them because it is the point that they both share. So we got one solution. What's it called? Consistent, independent, independent. All right. So that's our one graphing review. But obviously, if you're having trouble graphing, then we want to take a look at that. Classifying a system without graphing. All right, so what are we looking for? First thing I want to know is what's the slope? Are they the same? Are they different? Right? If they're different, this is awesome. Then we can be done with it. So the way these are formatted, they are not very helpful, right? I need to get y by itself in all of these equations. So I'm going to make it 2y. I'm going to add 3x to the other side. And then I can divide by 2. All right, so I know that 3/2 is my slope. What about this one? I get 2y. I'm going to subtract the x to the other side. So I get -x minus 8. I'm going to divide by 2. So this time my slope is -1/2 versus positive 3 over 2. So remember, this question is about classifying. So if my slopes are different, what solution will I have? Not the actual numeric solution. What do we call it? Right? Remember, that means I'm going to get one solution that's consistent. And it's also one, so it's independent. All right, so not too bad. So that's the first thing we're going to look for is the slope. We'll come back to what are we looking for if we need to in the next one. Hint, hint, right? All right, so same idea. I want 4y. I'm going to add 2x to the other side. So 2x plus 6 divided by 4. All right, so I got 1/2 x plus 3/2. Okay, it could be 1.5. Totally up to you. We're going to divide by 8. This one's a little bit slicker, right? A little bit faster. Y equals 1/2 x. Okay, so here's the thing. These are the same, right? So now I have to keep going. I have to find out, are my y-intercepts exactly the same? Well, we kind of know something's up here, right? Because it's going to be minus 12 over 8. 12 over 8, both divisible by 4, so 3 over 2. So I'm really trying to make sure you're paying attention, right? Because this is positive and this is negative. All right, so if I have the same slope with different y-intercepts, all right, is that the same line or are those parallel lines? Parallel lines. Okay, so we got to go through this thought process. If they're parallel lines, that means there's no solution. And if there's no solution, that means this is inconsistent. Inconsistent. All right, let's see what happens with the last one. Will we get the all real numbers? I don't know. Let's see. All right, so we got to add 2x, right? So y equals 2x minus 3. That one's done. And let's take a look at this one. We're going to subtract 6x to the other side. So I get negative 3y equals negative 6x plus 9. We're going to divide by negative 3. So y equals 2x minus 3. I get exactly the same thing. So I have the same slope. And I have the same y-intercept with the same sign, which means I have the same exact line graphed on top of the same exact line. So my solution is all real numbers. Remember, this was about classifying. So what are the words we used? All real numbers means we have a solution. So it's consistent. And one line lies dependent upon the other one. So they are dependent. All right, so that's how we deal with that. We're going to give you, a couple of graphs to do after we check in class. But for the most part, I'm really trying to drive in the vocabulary as well, because you should be familiar with the content itself. All right. The other thing is we can get a little bit better using a graphing calculator. So what we're looking for is any x values that have the same y value for both of the functions, right? So this is function 1, function 2. So I'm looking horizontally, and what I want to see is a match between any of these points. So where was it at? Okay, because I had all these different ones except for at negative 1, I got negative 5 for the first function and negative 5 for the second function. Okay, so what that means when I start to look at a table, and we can take a look in class how to do this on your graphing calculator, is negative 1, negative 5 is the point in which they cross. So if I can find a point like this, that means it's also going to be one solution, so it's consistent, independent. Okay, so what are we looking for in the table? I want x and I want y1 equal to y2. Okay, so that's what I'm looking for. I want both of the y values to be the same. All right, so where we're going to use some of this, we'll get a little bit further ahead. We're going to actually make some equations out of our Greenland shark and our spiny dogfish shark. We're not going to graph them at this point, but I just want to get a heads up on how to set them up. If the growth rate stays the same, at what age would the spiny dogfish and the Greenland shark be the same length? Okay, so that means one of them started off as a big boy here, and the other one's going to grow up to that. All right, so the Greenland shark, so we're going to start off at 37. Okay, so y equals, I don't know the slope yet because I didn't read that part, but it's 37 centimeters to get started with, and it grows at a rate of 0.75 versus the spiny dogfish shark. I didn't even know that was such a thing. So kudos to our biology kids who figured that out. All right, growth rate, this time I'll go in order. 1.5 centimeters per year, 1.5x, plus this one, 22 centimeters when it was born. All right, so what we're going to do here is just set up those equations. Will I get a solution? Absolutely. How do I know that? My slopes are different. My slopes are different. Okay, notice the one that started off smaller has a higher growth rate, so we'll catch the other one. We just don't know how many years it's going to take. All right, so quick preview to systems next week is we're going to show you what's going on. If you have a y equals and a y equals, what we'd love to do with these is set them equal to each other. All right, so that's all the preview I'm going to give you on this one, but I just want to put in front of you how we can use this type of systems of equations, even though we're not graphing at this time. Okay, so if you need some extra time, please take the time and review your vocabulary. Okay, to help with that, I'd like to see just 2 and 3 along with this 4 and 5. So if you can do that, then I know that we can work backwards through this whole thing by dealing with the vocab and creating a system that has it, and we'll touch base on that in class.